Hi, my name is Tim Diep. I'm a product manager at CA. So this is the final session for today. I'll be giving a demo of how AI and ML can be applied to probably one of the toughest problems in networking, which is to detect and troubleshoot application issues in the network. A few demos ago, Brian showed how we can use AI and ML to correlate user experience to infrastructure, to application performance. What I want to do is extend that and show you how we can use the same artificial intelligence and machine learning and correlate it to network troubleshooting. So he talked about mobile users having challenges in terms of buying something from text exchange application. We're going to assume that experience, that traffic goes through an SD-WAN network. I want to introduce SD-WAN because many of you are probably doing something in SD-WAN, and using AI and ML applying to SD-WAN will show you the power of the solution. So what you're seeing is our network operations analytics portal. And what this is an extension, is part of DXI, and it includes fault management, performance management, flow analysis, packet analysis, and the new SD-WAN monitoring. In this one portal, you can see that we're already detecting that there's something, there's an alarm that popped up on the screen that shows that there's a problem with text exchange. Now we know this because we're monitoring SD-WAN, and because it's SD-WAN, because it's application-centric, it's already defined application policies for the different applications that it carries. So in this case, you have text exchange, you have best effort, you have voice, and you can have video as well as other type of enterprise applications. This portal showing the alarm, if you click on the alarm, there's additional information you can see underneath. Now, having fault management embedded in the portal is important because now you can see you can take many actions that you usually do in network operation. You can create ticket, you can create performance report from the same page. You can trace route, you can ping, poll, and do other things that from a NOC standpoint that you can do. Going further down, looking into the specific alarm, you can see details of the alarm coming from the SD-WAN controller itself. You can see some analysis, some basic information about what might be the root cause. What's interesting also is that if you look at the symptoms, there were already alarms created about text exchange. There were two major alarms, and each one by itself did not raise a critical alarm. That's because the system, the DXI itself understands that SD-WAN has the ability to transfer traffic to another path. So when one path is down, it's not a catastrophic event. But now in this case, when both paths go down, it is catastrophic because there's no alternate path for the text exchange traffic to go through. So this is why you see critical alarm raised when both paths are down. This is an example of how we do fault suppression or fault correlation so that we can reduce the number of noise in your NOC. On the same page, as you proceed past fault management, you can start seeing performance monitoring. For SD-WAN, what we provide you is a geographic view of all your sites. In this example, we have 5 sites, but you could have 50, you could have 100, thousands of sites. And immediately we see that there is a site that's having problem. We know that the traffic is going through Dallas and San Jose, and we can see that Dallas is already indicating problems. If you hover over each site, you can see underlay information. This is the CPU, the resources for each site, the routers in each site. If I click on Dallas, I can see that there's a path that's having problem. If I hover over the path, I can see all the different application paths. So in SD-WAN, you have created this particular implementation, you have created paths for different applications. We can see that inside each of these, inside the tunnel, there are these application paths defined already. So to understand this further, what's happening, we're going to scroll down. We have what we call a time bar, in which you can see the individual sites as well as the application paths for each site. So for Dallas, you can see that there are a number of application paths. And you can see that there are problems with these paths. Further down, there's additional visualization for you to study each application path better. This is specifically on Dallas, on text exchange. We can see that text exchange is having problem in the internet link as well as MPLS link. We also provide events for you to do further analysis in terms of what other events might be causing the application path to have problems. So going back up, at this point, what we want to do is to drill into the text exchange application path issue and find out more information about it. In the network operations and analytics portal, we give you the ability to travel in context to different pages to diagnose the problem. So I'm going to click on the text exchange application path. There is a dedicated context page for the application path. You can see that is text exchange. You can see some summary information. You can see the specific application statistics, the name of the application path, the various information on it. Notice that there was an increase in latency, loss, and jitter at the specific time that the user was having experience. That is the correlation that we're doing using AI and ML. We still don't know the root cause at this point. So what we want to do is drill further down into the underlay. So from the same page in context, you can travel into the tunnel. The tunnel, the SD-WAN tunnel, is the one that's carrying all the different application paths. So right now we're looking at the bigger tunnel and seeing what's happening within the tunnel. There's some loss issue, and there's some packet issue also. We want to drill further, and we want to look at the interface itself. And we know we're specifically looking for a link, which is the internet link for that site. So I'm going to go down to the specific internet link. Now I can study further at the interface level what's happening. I can see that these charts showing the different SLA metrics, the latency, loss, and jitter. I can see the threshold settings for each one, as well as the actual data for each one. I can see that the latency and jitter are exceeding the threshold at some point in time. During the period, latency and jitter exceeded the threshold. I'm also looking at the different application and seeing that the percentage of time that best effort is within the threshold is very high, which is good, and voice is also very high, but for text change is not. So at this point, as a network engineer, my suspicion is that there is probably some sort of queuing problem, some sort of priority setting error. My remediation at this point is to say, let's set up a ticket, let's send a ticket to the provisioning team and reset the priority so that text change gets a better QoS priority than best effort. And that would be a logical remediation that was sent to fix this user experience problem. So this is an example of how we're using AI ML applied to a problem that has existed from the beginning of networking, which is to troubleshoot application problems in the network, as well as bringing in something that many of you are doing right now, which is SD-WAN. So combining SD-WAN with SNMP data, with REST data, with log data, with fault, flow, and packet, we're able to quickly help you troubleshoot the problem that started from a user having problem buying tickets from Text Exchange. So that concludes this part of the demo for me. What I want to also say is that in addition to solving this application troubleshooting problem, we're also advancing the solution to help tune the application so that in the case right now, you're remediating by changing the QoS. This type of actions can be automated by firing some sort of action to the SD-WAN controller. So that's the next step of the evolution of this solution. That ends the demo as well as the virtual summit. If you want more information about this particular part of the solution or any of the AIOps solution from CA, please go to ca.com/AIOps. Thank you very much for joining today, and have a great day.